This video is for the Novice 1 version of real-world problems that we will be working on with rate of change. We're going to be looking at a real-world problem and using rate of change to write an equation of a line. So we will go over the beginnings of the vocabulary that you need to do that and what each thing means in a real-life context. So this is Novice 1. So please follow along with the video and fill in your worksheet as we do it. So first, let me read the problem. There are many business situations in which the quantity of items sold depends on the price of the item. Market research has shown that attendance, A, at a small theater depends on the price, P, charged for tickets. To get a better picture of the relationship between attendance and price, take a look at this table. So our X values are the price in dollars, 0, 10, 20, 30, 40, 50, 60. Our attendance is the A. They wrote it in function notation here, so A of P. That's our Y values, our output. So it's 1,200, 1,100, 1,000, 900, 800, 700, 600. So the first question that we have to answer here says, use the numbers from the table to show that there's a constant rate of change, then find the constant rate of change of number of attendees per dollar, or slope, which we also call M. So if I'm looking at a table and I want to find a constant rate of change, I'm going to look at the change between each pair of points. So I'm going to start with the Y values. And I'm going to look at 1,200 to 1,100. So that's, if I do my subtraction, I'm going to do 1,100 minus 1,200. That's going to come out to a negative number because the attendance is decreasing. So it's negative 100. If I do the next pair, it'll be 1,000 minus 1,100, which is also going to be negative 100. So I want to show that it has a constant rate of change. So hopefully they'll continue to decrease by 100, or at least if they don't decrease by 100 when I find my rate, it'll still be constant. So the next pair, 900 minus 1,000 is also negative 100. 800 minus 900, negative 100. 700 minus 800 equals negative 100. And 600 minus 700 equals negative 100. Now you can do them in your calculator if you're not that good at subtracting when it's a smaller number minus a bigger number. But we notice that the rate for the Y values is decreasing by 100 as I go down. So the next thing I need to do is do the same thing for my X values. So if I go to the first change here, it's going to be 10 minus 0, which is 10. I'm going to continue doing that down the X values column for each pair of numbers, just like we did for the Y's. So I'm going to have 20 minus 10, which is also 10. Then I'm going to have 30 minus 20, which is also 10. 40 minus 30, which is also 10. 50 minus 40, which is also 10. And then lastly, 60 minus 50, which is also 10. So I've got an increase of 10. That's $10 is increasing as I go down. And if I look at the Y values, it's decreasing 100 people. 100 people. So I'm showing that it's constant by showing every ratio or every change between every pair of points. And then I'm going to write my ratio. They're all going to be the same because they're the same numbers going all the way down. So Part A asked us to find the constant rate of change, and they actually gave us M here to fill it in. So M would equal, now let's remember, change in Y over change in X, right? So change in Y over change in X will be negative 100 over 10. So I'm going to want to reduce that as low as I can. I know 10 goes into both of those numbers. 10 divided by 10 is 1. Negative 100 divided by 10 is negative 10. So my slope is negative 10 over 1. So I'm going to write that. M equals negative 10 over 1. Okay. And then what does this number tell you? So here's how we should structure our answer. As the attendance decreases by 10 people, which is our change in Y, the price increases by $1, which is our change in X. We could also answer that in the unsimplified version. We could say, as the attendance decreases by 100 people, the price increases by $10. But it's nicer to have the rate simplified if we can simplify it. So that's really what our rate tells us in a real life situation. It tells us if something is increasing or decreasing for every some number of whatever our X value is. So our Y is attendance, so attendance is decreasing by 10 people, because attendance is measured in people, for every $1 that they increase the ticket. So a ticket that was $10 might increase to $11, and then you'll have 10 less people go. All right, so the next thing we have to do is construct a scatter plot. So our graph is already scaled for us, which is really nice. So a scatter plot is just a bunch of points. So I'm going to take the points from the table, and then I'm going to graph them on the graph. Just by putting the points. I don't have to connect them, but I can if I want to. We'll see if the directions ask us to do that before we connect them. So first, I have 0, 1200. So I'm going to make a point up here at 0, 1200. Then I have 10, 1100. So 10 is going to be this box in between 0 and 20. 1100 is going to be between 1000 and 1200. And then 20, 1000. And then 30, 900. 40, 800. 50, 700. 60, 600. I'm going to stop for there. So there's my scatter plot of the data from my table. So the next part at the bottom, part C, says connect the points with a line. Make sure the line intersects the y-axis and passes through the points. So I'm going to take my ruler. I'm going to line the points up with a ruler. And I'm going to make my line nice and long. I want it to make sure it intersects the y-axis, which is the one over here on the left, and that all the points are connected. So let me do that. There we go. Okay, so this is what your graph should look like. You should have all those points. We should have 7 points and then a line going through them both directions. I made it go long in both directions just so that I have it nice and clear where it is. All right, we're going to flip over to the back. Okay, onto the back. Part D says where, and that's bolded because that's important. Where does your line intersect the y-axis? This is your y-intercept, also known as B. So M is what we give to slope. That's the letter we use for slope, the variable. B is the variable we're going to use for what we call the y-intercept. So we want to know where on the graph does the line that I just drew intercept the y-axis. Let me flip over. Looking at our graph, over here is the y-axis. So we're looking at where is this line intersecting. So if I follow the line until I get to the y-axis, it's intersecting right here. So that's our B value. And where is that? Well, I have to look at what number that's at. It's at 1200. So when I go back to the other side, B is going to equal 1,200 or 1,200. And what does that number tell us? Well, that tells us some information about the ticket price and the attendance. When the ticket price is blank, there are blank people attending the theater. So 1,200 was the number that was on the y-axis, which means that was our attendance. So we can fill that in here in front of people. So when the ticket price is blank, there are 1,200 people attending the theater. So let's look at what our ticket price was at that point. I'm going to flip over again. So at that point where I have the B, 1,200, that's our ticket price. But when I look down here for what our attendance is, I'm at the corner, which means it's 0. Our ticket price is $0, and 1,200 people go. So that's a free ticket. So they're handing out free tickets. 1,200 people are attending. When they had $10 tickets, 1,100 people are attending. When they had $20 tickets, 1,000 people. $30 tickets, 900 people. So when it was a free ticket, so when X is 0, when our price is $0, 1,200 people attend. So when the price is $0, there are 1,200 people attending the theater. All right, question E. This is where we're going to start to build our equation. Substitute m and b into y equals mx plus b to create a linear equation. Keep the y and the x and the equal sign. So notice we have the equation filled in. Y equals blank x plus blank. We calculated our m at the beginning. That was our answer to question A. And we found b on the graph in part D. So all we have to do is fill those numbers in. So if I flip back to look at m we had negative 10 over 1. So I'm going to write that in the m spot. And then b we just figured out was up here, 1,200. So I'm going to write that in the b spot. And then there's our equation. Y equals negative 10 over 1x plus 1,200. So the coefficient, or the number in front of the x, is our slope, our rate of change. The number that's added on y-intercept. So now part F. Use your equation from part E to predict how many people would attend if the ticket price was $120. Extend your graph and plot this point. What is the significance of this point? So we're going to substitute in $120. So we have to know, is that our x or is that our y? Our x is measuring price, so that 120 is going to go in for x. Let me write my equation down. Y equals negative 10 over 1 x plus 1,200. In the x spot, I'm going to rewrite it and put 120 instead of x. Y equals negative 10 over 1 times 120 plus 1,200. And I want to calculate what the attendance is going to be. So I'm going to pick up my calculator. I'm going to type in negative 10 over 1. So that's negative 10 divided by 1 times 120 plus 1,200. I'm going to get a number. So I'm going to get negative 1,200 plus 1,200. Negative 1,200 plus 1,200 is going to be 0. And so what does that mean? It means when the ticket price is $120, there will be 0 people attending the theater. So that means if I'm looking at a point that's 120 for my x and 0 for my y. This is called the x-intercept. So let's graph that quickly on the graph. We'll see where that is. Flip it over. $120, 0 people is going to be a point right here. So this is called my x-intercept. That is where the graph, my line, meaning my line, is intercepting the x-axis, which is down here. So 120, 0. And there you have it. Feel free to go back and look at the video at any point that you need. Rewind, rewatch, or pause just to check your answers. Thank you.